One of the challenges when it comes to becoming a programmer or a software engineer is that you need to always have this balance of knowledge when it comes to system design and detailed low level implementations or step by step implementations of your solution. So, this is commonly known as your algorithm or your recipe to solving a given problem. So, generally, if you are consistently focusing on the low level implementations, you'd be lost in the weeds or the trenches of the graph that you are exploring. But if you are focusing on system design, you generally want to focus on high level features which are suitable for you enough so that you could get a general grasp and dynamics of how a system is going to work. So you can see how these two um, topics are on a perpendicular spectrum where they're somewhat orthogonal to each other, and you might have to balance out the two when you're dealing with a specific problem to solve. So generally, when you're given a specific problem to solve, you start with system design because yeah, you generally want to have an overview of what the system is going to do. That means the functionalities and some other also non-functional requirements such as uh, how how good the system is going to be when it comes to um, handling some qualitative aspects of the solution. So you generally want to uh, so I focus on system design immediately when I'm approaching a problem, but doing system design indefinitely could also lead you in a loop or in a computation pattern where you don't really know what you're accomplishing after some point because system design could go only further as much as giving you a blueprint and you need to go out there and actually search for resources that could actually match your system design that you have already implemented. So even that conversion from a specific design to an actual implementation of code is also a skill, which comes to engineering, definitely. So architecting the initial design, you can architect a very beautiful piece of system, but then at the end of the day, when it's implemented, um, if 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 the architecture is uh, way too deep when it comes to the actual design, the specific resources, or it might not be adaptive enough. So you might want to know when to transition to implementation. So there are a lot of approaches to this, but usually we design just enough to initiate an implementation process where we can immediately get started on working on delivering the solution because most approaches these days are agile. We don't wait until the whole design is finished to get started working because somehow design just or system design engineers or generally senior software engineers often um, will get the process going of the development process going simply if they know um, or have a common ground of understanding. So once you have that common ground of understanding to what the system looks like, everybody could go there and start implementing their solution. But it's not that easy because again, at the individual level, then the all the problems trickle down recursively, and this recursive trickling down of the problems actually translates to the individual problem solving skills as well. So the smaller the problems get, the better the lower level problem solving skills of that person should be. So that's where this trade-off should come. So just the fact that somebody is good at high level design or system design doesn't mean they're good at a specific problem solving skill set, but they can be because they can somehow balance out and do a trade-off. But it's a good it's a good tension that a person can manage so that they could be both agile enough to go high level when needed and low level when necessary as well. So it's this tug and pull as a software engineer. In fact, one gets adapted to after a while. So this is just something on the top of my head, and something I've been looking into recently. So I would probably try to add more video of this. Thank you for listening.